Hello class, we are at the end of our Unit 8 Trigonometry flipbook. It is section number 5. The bottom flap is labeled Solve Right Triangles. And the essential question is, how do I solve right triangles using trigonometry? And when you hear the word solve right triangles, basically what that means is find all the missing sides and all the missing angles. So if I ask you on a test to solve a right triangle, you got to look at the information I gave you and figure out all the missing information. And class, you should always then label your diagram so you are certain you have found all of the missing pieces of information. So let's take a look at our first question. Find all the missing side and angle measures. Okay. Let's work on sides first, since that's going to take a little longer. And before I do that, class, I don't know if you can hear this or not, but someone's having a party in my neighborhood, and I can hear the music blasting through my front window. So I figured I would blast them out. So let's see. Let me see if I can do this. Let's get a little 80s rock going here. So anyway, some of you had asked for some music on a video, so there you go. You've seen I've written SOHCAHTOA. I've labeled hypotenuse, opposite, and adjacent based on the known angle. So I'm going to go ahead and find the sides first. Now I'm going to skip some steps now, class, because I've been doing my homework, and I've been doing the flip books, and I've been doing all the rest of it, and I should be getting good at this. So I'm going to go ahead and find BC first. Makes no difference. Let's go ahead and find BC first. So we're going to go ahead and use angle A. So I'm going to put on here, I'm going to use angle A as my reference. And let's see, angle A. I know adjacent and I want to know opposite. So adjacent and opposite is tangent. So I can go right to my trig function. Tangent of 41. Tangent is opposite over adjacent. Opposite I don't know. It's going to be my side BC. Adjacent I know, and that's 42. My variables in the numerator, so I'm going to multiply both sides by 42, and that gets my side BC by itself. 42 times tangent of 41 equals our unknown side BC. And let's go ahead and plug that into our calculator. BC is going to be approximately, let's take a look, we got 42 times, see, can you guys hear the music in the background? Someone's blasting their tunes, and it's music I probably don't like. 42 times tangent of 41 is 36.51. Let's make it 36.5. So approximately 36.5. Our unit of measure is feet. So here's what I'm going to do, class. I'm going to label that 36.5 feet. When you solve a triangle, label the parts as you go. Alright, let's go ahead and find the length of AB, which is our hypotenuse. So I'm going to draw a line in between these so we can see the difference. And let's try a different color. Alright, so we're going to be looking for AB now. Now our reference angle, we might as well just use the same one since we know it. We're going to use angle A. So let's see, angle A, I know adjacent, I want to know hypotenuse. Adjacent hypotenuse is cosine. So my trig function is going to be cosine, same angle, 48. It's adjacent over hypotenuse, which is 42 over an unknown, AB. Now in this case, class, the 42 is on top, our variable is on bottom, and now we can do the Algebra 1 switch. Cosine 41 goes in the bottom of the fraction, AB goes where cosine of 41 is. So AB is equal to 42 over cosine of 41. Let's go ahead and put that in our calculator. So 42 divided by cosine of 41 equals, and that is 55.65. That 5 means we're going to round it up to 7, so 55.7. So let me scroll here. AB is approximately 55.7 feet. So I will go ahead and label that on our hypotenuse. 55.7 feet. Now we can see, class, we've got all our side measures. 42, 36.5, 55.7. Let's go ahead and figure out our angles. And this part is easy because we've already been given one angle, and that means we know that the measure of angle B must be 90 minus 41. Remember, one of our angles is already a right angle. That means we only have 90 degrees left to split between angle A and angle B. So the measure of angle B is equal to 49 degrees. So I can go ahead and label the triangle 49 degrees, and you can see all of our angles and all of our sides have now been solved. Let's go ahead and take a look at the next one. Find all the missing side and angle measures. I would suggest, class, you pause the video and do this one on your own first, and then come back and see how you did. If you've already tried now and you started the video back again, I'm going to go through my normal routine. So Katoa, the angle I know is R. This is going to be our hypotenuse. This is going to be adjacent. Let me write it a little bit further over so we have room to write the actual side length. This is going to be opposite. And let's do our sides first, since that's the longest part. So sides. Let me see. I'm going to try for RS first. So we'll do RS. Okay, we're going to use, of course, angle R, our known angle. Okay, using angle R, RS is adjacent. We want adjacent, and we know hypotenuse. Adjacent and hypotenuse is cosine. So we're going to be using cosine of 31 is equal to, well, our adjacent is the unknown, that's RS. Our hypotenuse is 200. Since our variable is on top and our known value is in the denominator, we multiply both sides by 200, and it's 200 times cosine of 31 equals the length of RS. And let's go ahead and do the math. RS is approximately, I'll slide this over. Let's see, you've got 200 times cosine of 31 degrees equals 171.43. We can drop the 3. 171.4. 171.4. Our unit of measure is meters. Let's label that 171.4 meters. Alright, let's draw a line and do our other side. Now some students are saying, Mr. Z, can I use Pythagorean theorem now? Absolutely. You can use Pythagorean theorem, but if you do, you better round this RS to 2 decimal places so you get a more accurate answer. I'm going to go ahead and use trig because, as you can see, the more you work at it, the easier it gets. So in this case, we have to find ST. ST, we're going to still use angle R just like we did before. ST is opposite of R, opposite, and we already knew hypotenuse. Opposite over hypotenuse is sine, so we know we're going to use sine of 31 degrees is equal to our unknown ST over our known hypotenuse of 200. Look how similar it is to our previous one. We move the 200 to the other side by multiplying both sides of our equation by 200. That gets rid of the denominator. Equals ST. And so ST is approximately, let's take a look, 200 times sine of 31 degrees equals, and it is 103.00, so 103, 103.0, and this is meters. So let's go ahead and label that. Our opposite is 103.0 meters. All the hard part is done. Let's go ahead and find our angles. There's only one to find. Class, if you're given an angle and the right angle, you don't need to use trig or inverse trig. If you have no angles at all, you have to use inverse trig. So the measure of our unknown angle T is equal to 90 minus 31, which is equal to 59 degrees. Let's go ahead and label that 59 degrees. And our triangle has been solved. One more thing, class. If you ever want to check your work, just take a look at this triangle. You know that 200 is the hypotenuse. That has to be the biggest side always. If you got the answer for RS is greater than 200, stop. You know it's wrong. If you got the answer for opposite is greater than 200, stop. You know it's wrong. And then one more thing for you guys to know. The biggest acute angle here is 59 degrees. The smaller one is 31. Look at the sides that are opposite that. 31 connects to 103. 59 is opposite of 171. This adjacent side has to be bigger than opposite because the angle that is across from that side is bigger than the angle that is across from the opposite side. So this is a couple ways that you can look and just make sure your answer makes sense. Look at our first question. Hypotenuse is 55.7, that is the longest side. 41 degrees is smaller than 49. That means this side, opposite, better be smaller than this side, which is across from B, 42, and that makes sense. So our answers look like they are making sense. This is how to solve a right triangle.